Welcome back. In part 3, we are creating our first Linux virtual machine in Azure using Terraform. By the end of this series, you'll feel confident working with Terraform and Azure in real-world scenarios. You can find the full source code in the GitHub link below. Let's get started. On the left side, the Terraform code structure. In part 1, everything lived in a single file, main.tf. That worked for learning, but it wasn't scalable. In part 2, we improved the structure by separating the provider into provider.tf. The project became cleaner and more organized. And now, in part 3, this part, we take it further. We introduce variables.tf, outputs.tf, and Terraform.tf vars. Now the project is modular, configurable, and much closer to how real-world Terraform projects are structured. So we're no longer just creating resources, we're designing infrastructure properly. Let's move to the right side, the infrastructure view. We already have the foundation and network in place. In this video, we're adding the compute layer and our first virtual machine. Notice something important. We're not recreating existing resources. Instead, we reuse the infrastructure and deploy the VM into the existing subnet and resource group. So this reflects the layer infrastructure design: foundation, networking, then compute, with clear dependencies between each layer. Now let's deploy our first virtual machine. What is a virtual machine? A virtual machine, or VM, is a server that runs in the cloud instead of on physical hardware. Azure provides virtual CPU, memory, storage, and networking resources, and together they behave like a real server. You can install an operation system, deploy applications, host websites, and run databases, just like on a physical machine, but without worrying about buying or maintaining hardware. We need to have these items when we want to have a virtual machine. Subscription defines where the VM is built and managed. It controls costs, permissions, and access to Azure resources. Resource group, a logic container and groups related resources together. It helps you manage, organize, and delete resources as a single unit. VM name, the unit identifier of your server inside Azure. It helps you easily find and manage the VM later. Region, the Azure data center location where the VM runs. Choosing the right region affects latency, compliance, availability, and sometimes costs. Image, or operation system. The operation system installed on the VM, such as Ubuntu Linux. It defines the base environment where your applications will run. And VM size defines the amount of CPU and memory assigned to the VM. This directly impacts performance, scalability, and pricing. And administrator account defines how you securely access the VM. For Linux machines, we typically use a username and an SSH key for authentication. And VNet, as we mentioned before, defines the network environment where the VM operates. It controls IP addressing, subnets, and how the VM communicates with the other resources. Finally, storage defines the disks attached to the VM. There is always an OS disk and optionally additional data disk depending on your workload. So a virtual machine is not just a server, it's compute, storage, and networking combined to deliver a flexible and a scalable cloud environment. And let's go and check how we can create a virtual machine on Azure Portal. So these are our resources here in Azure Portal. This is a resource group we created in part 1, and this is a virtual network we created in part 2. If we go to resource group, we can see we have virtual network here. And also if I click on our virtual network, we can see our subnet that we created in part 2. Now let's look at how we can create a virtual machine in Azure Portal. If we go to virtual machines and if we click on create and virtual machine, So here in basic tabs, we configure the core setting. So subscription, we can choose our resource group, that is rg-tf-demo, which are names, region, availability options. We don't need it in this step. So, and also we can see the image, size, and other option we can configure for creating this virtual machine. So when we select the image, Azure automatically prepares the operation system disk for us and assigns a default storage configuration. So it means the OS disk and its type are pre-selected automatically, although we can customize them if we need it. So we already chose Ubuntu server here, and if we go to disks, you can see it's already selected, and also we can customize it to whatever we want. And also about networking. In networking tab, notice something is important. The virtual network is always selected automatically. That's because we chose the resource group and region earlier, and this VNet already exists there. And so Azure intelligently suggests the existing network that's belonging to that environment. When we click Review and Create, Azure validates everything. If something is missing or incorrectly configured, Azure will tell us exactly what needs to be fixed before deployment. So we can see here we have some errors here. So we didn't select the name like new VM. So if we hit the review and create a game, and once validation passes, we can create the virtual machine. And also if we check the estimated monthly costs, we can see $8.993 per month. This estimated monthly cost shows us how much the VM will cost while we're creating it. And now, instead of doing this manually in the portal, we are going to create the same basic virtual machine using Terraform code. So this is our structured Terraform project. We've separated the configuration into dedicated files. Now let's look at the implementation. And also in this example, we keep things simple. The VM has no public IP. It's connected to the existing subnet, and we use username and password authentication. And let's check our code in VS Code. So I'm gonna enable Zen mode. Now it's better. First, we define our variables in variables.tf. This file describes the inputs our configuration expects. It doesn't contain real values, only definition. As you can see, we have location, RG name, VNet name, subnet, and all of our variables here. And this makes the configuration reusable. The logic stays the same, but the values can change. Next, we use terraform.tf-vars. This file contains the real values for our environments. For example, location is Canada Central. Our resource group name is rg-tf-demo that we already created. So you can think of it like this. Variables.tf defines what we need, and terraform.tf-vars provides the actual values. Let's move to main.tf, where the infrastructure is created. First, we read existing resource group with data Azure RM resource group, RG. This tells Terraform to reuse resource group we created earlier. And we also read the existing virtual network and subnet with this piece of code. So this keeps our infrastructure connected and layered. And also you can see we're gonna call our subnet from Azure. So next we create network interface. A VM does not connect directly to a subnet. It connects through a NIC. There is no public IP configured here, so this VM will only receive a private IP address from the subnet. And now let's talk about authentication. Inside the VM resource, we define admin username and admin password. This means we allow password authentication, and we are not using SSH keys in this example. And in production environments, SSH keys are usually preferred, but for demonstration purposes, password authentication is easier to show and understand. Let's move to outputs.tf. This file exposes useful information after deployment. For example, output VM ID and also private IP address. So after applying our Terraform code, we can see our VM ID and also private IP. Outputs allow us to see important values after Terraform apply, pass values to other modules, and connect feature infrastructure layers. And finally, provider.tf connects Terraform to Azure and defines the required versions, as we mentioned before. So to summarize, variables.tf defines what inputs we need. Terraform's.tf vars provides real environment values. Main.tf builds the infrastructure. Outputs.tf exposes important results. And provider.tf tells Terraform which platform we are working with and connect it to Azure. And the VM is created without a public IP, and authentication is handled using username and password. This keeps the example simple, clean, and easy to understand. So let's go and run our Terraform code. So first, we run Terraform init. This initializes the working directory and downloads the required provider. Before applying the changes, let's make this more production ready. Instead of running Terraform apply directly, we can first save the execution plan to a file like Terraform plan, and if we use -out equals tf plan. What this does is generate the execution plan and store in a file called tf plan. So why this matters? In simple demos, running Terraform apply directly is fine, but in real production environments, we want more control. By saving the plan, we make sure that the reviewed plan is exactly what gets applied. No unexpected changes happen between plan and apply, and we have a clear approval step before deployment. So tf plan saves the planned changes before we apply them. Now, instead of running Terraform apply, we apply the save plan file. We run Terraform apply tf plan. This guarantees that Terraform executes the exact actions we reviewed earlier. So yeah, it's done. Now I'm gonna verify that, and also you can see here private IP address is 10.0.4, and this is our VM ID that I'm gonna blur it. And let's switch to Azure Portal to visually verify everything. So let's go to find our virtual machine. We need to go to home. So if we go to our resource group, and you can see the virtual machine here, our network interface, and OS disks. And since the VM does not have a public IP address, we cannot connect to it directly from the internet. So instead, we use Azure Bastion. Azure Bastion allows us to securely connect to VM inside a virtual network without exposing it to the public internet. So we can find it here under Connect, and when we hit the Bastion here, we can see it asks us about username and password. I'm gonna use the username and password that I mentioned in our Terraform code. Also, it has different authentication types. So we'll cover Azure Bastion in the future video. For now, just know it allows secure access to private VMs without a public IP address. So now we successfully built our infrastructure with Terraform, created a Linux virtual machine, verified it in Azure. Before we finish, one very important step. Since this is a demo environment, we don't want it running and generating unnecessary costs. So let's clean everything up using Terraform. We use Terraform destroy. So Terraform will now remove all the resources it's created, keeping our Azure environment clean and cost-free. That's one of the biggest advantages of the infrastructure as code. We can create and remove environments safely and predictably. Okay, now destroy completed and 2 resources destroyed. In the next part, we are going to take this further. We'll talk about Terraform modules and how to make our infrastructure reusable and cleaner. And we'll also focus on securing our Azure VM, because building infrastructure is only half the job. Securing it properly makes it production ready. See you in the next part.